Alright, let's break down how a nuclear reactor works. We'll explore the core principles and processes that allow these facilities to generate substantial amounts of energy. And don't worry, I'll keep it simple. We'll avoid getting bogged down in complex technical jargon and focus on the fundamental concepts. My goal is to provide a clear and accessible explanation for everyone. Think of a nuclear reactor as a supercharged kettle, but instead of just making a cup of tea, it's producing enough steam to power entire cities. Instead of burning coal or gas, which releases greenhouse gases into the atmosphere, it uses the power of atoms splitting apart, nuclear fission. This process unlocks tremendous energy from within the atom itself, to boil water and make electricity. This electricity then powers our homes, businesses, and infrastructure. At the center of it all is the reactor core, the heart of the entire operation. That's where you'll find fuel rods packed with uranium-235, a specific isotope of uranium that's particularly good at undergoing fission, or plutonium-239, another fissile material that can be used as nuclear fuel. Here's the cool part. When a neutron, a tiny subatomic particle, hits one of these atoms, the atom splits. Bam! It's a rapid and forceful reaction, releasing a burst of energy as heat, along with more neutrons. This heat is what we're after, and the extra neutrons are key to the next step. These new neutrons then go on to split more atoms, creating a cascade effect, creating a chain reaction that keeps the heat coming. It's a self-sustaining process as long as there's enough fissile material. Now all that heat needs to go somewhere. It can't just stay concentrated in the core. The core sits in coolant, usually water, although other coolants like liquid sodium can also be used, which soaks up the heat like a sponge. The coolant circulates around the fuel rods, absorbing the thermal energy produced by fission. This hot coolant is then pumped through a heat exchanger, a crucial piece of equipment, where it comes into contact with a separate loop of clean water. This separation is important for safety, preventing radioactive contamination. The heat jumps over, turning that clean water into steam, creating high-pressure steam. But the radioactive stuff stays safely contained within the reactor and its shielding. Multiple layers of safety systems are in place to prevent any leaks. Here's where it gets really clever, as we convert that thermal energy into mechanical energy. The high-pressure steam is funneled towards a turbine, a device designed to capture the energy of moving steam, a giant spinning fan with precisely engineered blades. As the steam hits the blades, it turns the turbine, converting the thermal energy of the steam into rotational kinetic energy, which is hooked up to a generator, a device that converts mechanical energy into electrical energy. Spin equals electricity. The faster the turbine spins, the more electricity is generated. That's how the power gets from the reactor through the power grid to your home. After the steam does its job of spinning the turbine, it needs to cool off and condense back into water. So it heads to a cooling tower, a large structure designed to dissipate heat, where it condenses back into water, releasing the remaining heat into the atmosphere. That water is then sent right back into the system to start the process all over again, creating a closed-loop system that conserves water. It's a non-stop cycle. Split, heat, steam, spin, cool, repeat. This continuous process ensures a steady supply of electricity, but you might be wondering, is it safe? That's a valid and important question. Nuclear reactors have serious safety features designed to prevent accidents and protect the public. Control rods made of neutron-absorbing materials can be lowered into the core to soak up stray neutrons and slow down or even stop the chain reaction, effectively shutting down the reactor in an emergency. Plus, there are multiple cooling systems and big, tough containment buildings constructed from reinforced concrete and steel to keep any radiation locked away, even if something goes wrong. These buildings are designed to withstand extreme events. So, in a nutshell, a nuclear reactor is a high-tech machine, a marvel of engineering. That uses the power of atom splitting to create massive amounts of electricity, providing a significant portion of our energy needs. Cleanly and efficiently, without producing the same level of greenhouse gas emissions as fossil fuels. Next time you flick a light switch, remember, there might just be a bit of nuclear magic behind it, powering your life in a silent and powerful way.